Best time to buy and sell stock with Cooldown. You are given an array of prices where prices I value is the price of a given stock on the I day. Find the maximum profit you can achieve. You may complete as many transactions as you like. Um, Buy one and sell one share of the stock multiple times with the following restrictions. After you sell your stock, you cannot buy the stock on the next day, cooldown day. You may not engage in multiple transactions simultaneously. You must sell the stock before you buy again. So this example one, we have prices, a prices list, and it says the output 3. So this means that the maximum profit is 3 because it says we can buy on the first day, buy, then sell, then cool down. So this here's a profit 1, cool down, buy again, and sell. So the profit here is 2. So 2 plus 1, 3. That's how we get this output. That's the maximum we can get from this. So now here we only have prices in this example, and this 1 and output 0. So let's take care of this edge case over here. Let's call it if length of prices is equals to 0, or prices or not prices, I meant, or not, so not prices, return prices. So this is a dynamic programming. So let's take n and make it equals to the line of prices, and then let's make an array too. Let's store the appropriate values to the corresponding variables. Create variables to store the values to corresponding variables. Let's call the first one DP. Hold on, no, there's no need to do that. Let's call it hold. Let's hold and equals to n times, no, let's call it 0. So let's make all the values in 0 for now to hold our place. The first one will be 0 for now. So let's just create that. Oops, this should be n. And then let's make our solo cell. Let me call it cell equals to 0 plus n times n, and then rest will be the same. 0 times per times n. So now let's make our base cases. Let's make whole in the first index equals to let's make a negative price after we buy. Prices equals to the first value price. Let's call it after buying price will be no to buy will be negative after buying on the first day, and the first day value will be negative. And then let's make sale, and let's just give it 0. So we can't sell on the first day because we didn't buy yet. And then pressed. Do nothing. Don't do anything. So let's make iteration to go through the days to do to make, to buy, sell, rest with relation to stocks, then store our profits in the appropriate arrays. Iteration from the second day, which is index to no 1 to n last day of stocks. So slash prices list. So let's go to it. Let's do it for I in range of 1 to n, and then let's make a hold I will be equals to the maximum, whichever is larger. Hold I equals, and no, oops, -1. Hold on the previous day, let's rest I -1, I -1, plus the price. No, minus the price. Prices I. So this will basically keep holding or buy stock. Sell. Now let's make a sell. Oops, I just saw this. This should be a 0. So sell I is equals to we have to have a hold first before selling. So hold I -1 the previous day and then add the price to it plus prices I. I forgot that's over here. And then let's go to sell. We can only sell for in the stock. So now rest. Rest will be I. Rest I will be equals to the maximum of rest I itself. I minus one. Is it selling? Oh, sell. We can continue listing. We can continue listing on the previous day of buy stock. And that's it. That's pretty much it. So let's make return. So now let's return the last the maximum value of the last the maximum of the last return. Whichever is the last and the largest from cell of rest array. Return return maximum of rest negative cell cell negative I. And that's it. It's been accepted without any syntax errors this time. And our time and space complexities are both time and space complexities are both O of n, because if you go to the days for time complexity, going to the stocks will just increase linearly, and our space complexities will be stored also linearly with depending on how much we have on each variable. And that's it for this problem. Let's submit to see if it's going to pass all cases. And it's been able to pass all cases efficiently. And that's all for this problem.